and it wouldn't work. But I'm not 100% sure if it might not have been processing through Google, and so that's why it wouldn't work. And I'm going to email them and ask them to try again and see if it works today. So we may or may not have that. Still trying to figure out what's going on with all that. But in the meantime, you get to be taught, and so it doesn't matter if there is a live stream. Guys, what we're going to be talking about today is mathematical modeling with quadratics. Why quadratics specifically? Well, thing one, they're far more interesting than lines. Linear functions are boring and dull, but yeah, they're occasionally useful. You know, every Saturday I swing by my bank and I put $20 in my bank account. Boom, I got a linear model. Predict how much money I will have in my bank account at any given time, assuming it doesn't pay interest, which bank accounts don't. But quadratics are actually super useful because it turns out that anything that flies through the air in a gravitational field makes quadratic. You a good catch? Yeah. Good. It's nice and squishy, so even if you miss, it won't hurt anything. Catch. Did you guys see the quadratic?
Of course I did.
Made a nice arc, didn't it? Mm-hmm. Here, we'll see another one real quick when he throws it back. You launch a rocket, the rocket motor goes, thing goes straight up and down, the rocket motor quits. What does the rocket do? It forms a quadratic. Goes up, comes back down again. Anything flying through the air, not under power, not being pushed by a motor, anything flying through the air in gravity, so on the Earth, on the Moon, Jupiter, will travel in a parabola, which makes modeling with quadratics super, super useful because so much of the time when we're talking about now what, we can say, oh, well, you know, it's going to go up, come back down again. And it's going to be a parabola, it's going to have a vertex, and it's going to have a stretch factor. All these things that we've already talked about, it's going to have all of those. So all we got to do is get some data points, and then we can say, oh, look, there's the equation of the parabola. And what we're going to do right now is figure out how to find the equation, and that's what we call mathematical modeling. Because from then on, you can use that equation to predict for that situation. In a new situation, got to come up with a new parabola. So let's take a look at a scenario. We have a fence. It is 3 feet high. We have ground, because, you know, you got to have something to hold the fence up. You guys know what jackrabbits are? Really big rabbits. Find them down in Texas, Oklahoma, those areas. They're really big rabbits. So we got a jackrabbit, and no making fun of my drawing, because I know that's what comes next. And, Mr. Armory, that doesn't look like a rabbit at all.
I'm very concerned.
I'm a math teacher, not an art teacher. Okay? You want a drawing of a rabbit?
At least give it an eye.
If you want a drawing of a rabbit, ask Mr. Holtz. But then when you ask him to do the math, he'll say, I don't know what you're talking about. So this jackrabbit leaves the ground and just clears the fence and then lands on the ground over here. And he leaves the ground 4 feet from the fence, and he lands 4 feet from the fence. Now, what does our equation of a quadratic look like? We are going to use the vertex form of the quadratic. what I would like you to do right now, I would like you to just take about 30 seconds and think to yourself, if this were a graph, what points do I know on the graph? What points do I, just looking at that diagram and visualizing, oh, that's a graph, what points do I have? You guys know about Pavlov's dog? Pavlov's dog was an experiment in autonomic reaction. Autonomic reaction are reactions you can't help, they're automatic. So for example, if something smells really bad, you make a face. Why? Doesn't make it smell any different. But most people make a face if something smells really bad. That's an autonomic reaction. So Pavlov did an experiment where he had a dog, and what he would do is he would ring a little bell and he'd put the dog's food in front of him. And the dog would start drooling and eat its food. And then after he got the dog expecting when you ring the bell you get the food, he would just ring the bell but not give him food. And the dog would start drooling even though there was no food there. And so it's called Pavlov's dog. I have this dream that all my math students, when I'm drawing popsicle sticks with their names on them to ask them math questions, that 10, 15, 20 years from now, you'll hear that noise, and you'll immediately think, oh, someone's going to ask me a math question. That's my dream, anyway. Amrit, what points do I know on this graph?
Well, if you assume that the peak of his jump was over the fence, you could say that the vertex of it would be 0, 3.
Let's do that. Let's make that assumption. There is the vertex at 0, 3.
And then on the left side, the lowest point would be 3, 4.
Why 3, 4, just out of curiosity?
Oh no. Yeah, because it's 3 down from top, which is 0, 3.
But wouldn't that mean that this was 0, 0? If you're going to say then I go down 3.
Oh, okay, I see. So then it would be 0, 3. Would it be -1?
What do you guys think?
It'd be -4, 0.
-4, 0. If we're going to assume that this is the y-axis and that's 3 feet high, must that not be the origin? Makes sense, right? And so then this point over here is -4, 0. And how about this point right here? Yeah, 4, 0. So we now know 3 points on this graph of the parabola. You know it's a parabola because it has to be physics. The law. I'm not allowed to change that. So next question is, of all that information we now have, can we put anything into that equation?
Would the K be 3?
A?
K.
K. Would K be 3? What do you guys think? We agree with that? Anything else? Here, let me draw the stuff that we don't have to worry about. There we go. What else? If K is 3, do we know, is there some other number that we must automatically know?
H.
0.
Roberto?
X would be 0 in that one.
X would be 0? Why? Explain.
H be 0?
Melissa?
Wouldn't H be 0?
Why?
Because that's the vertex.
That's the vertex. H comma K is the vertex. So H must be 0. So let's make a little list over here. H is 0, K is 0. Okay? Anything else?
You mean K is 3?
A is negative.
That's what I said. A is negative. I will agree with that, but you know, right now, I'm not going to care. And there's a reason I don't want to care. If I calculate A, I know it's going to be a negative. That's where we're going to go with that. We're going to calculate A, and it's going to be a negative. If I put a negative there right now, then when I calculate A, it will be a positive, and I'll have to remember to stick the negative in front of it. And so I just want to leave it alone. I just want to just completely ignore A. Do I know what A is equal to? Do I know the stretch factor? Can we tell what the stretch factor is just by looking at a parabola? The answer is, so I don't know what A is. You know what? Let's change colors just so our unknown is a different color. There we go. A. Now, the only thing missing from this right here is Y and X. Can I write anything in there?
You can write Y.
Just the letter Y?
Oh, wait, no.
I could.
Yeah.
Do you want me to? Happy to. I mean, okay. What else? What's the only thing I'm missing? Should I just put an X there? How many unknowns? Well, that's awkward. Can I solve if I got 3 unknowns?
No.
Because there's an infinite number of possibilities, aren't there? Let's go back a step. What do I know that could help me here? Well,
You know that there's a dot at 0x and 3y. There's a point.
what? 0x? But
Yeah.
X is an unknown. If I'm going to say 0x,
Oh.
I'm a little
Okay.
unsure about that. What do I know? What information have I not used yet at all? That information, have I used that yet?
No.
Could that go into my equation somewhere? What does 4 comma 0 represent on this graph?
X-intercept.
X-intercept? What else?
Distance from the fence.
Distance from the fence, although that's just 4 feet as opposed to 4 comma 0. Isn't that just a point on the graph? It's a specific point, it's the intercept. But do we agree that it is just a point on the graph? So what does the 4 and the 0 tell me if 4 comma 0 is a point on the graph? What does 4 comma 0 represent if we say that's a point on a graph? What do those two numbers tell you?
The possibilities.
One of the possibilities of what? And what about the parabola?
The equation.
What about the equation?
You can get them out of the equation.
Yeah?
Oh, just plug them
You can
in.
plug them in. And solve
Plug them in where?
the X and Y.
Ah! Boom! That's an X value, and that's a Y value. I know you're thinking, but wait, that was really easy, Mr. Armory. Why did it take us like 8 minutes to come up with it? Because we stopped thinking about these things over the years. We're so used to, hey, 3 comma 5. 1, 2, 3, 1, 2, 3, 4, 5, dot. What does that represent? Well, it's a 3 and a 5. I went over 3 and up 5. What does it represent? Over 3 and up 5. But what does it represent? It's a point on the graph. But what does it represent? Oh, it's an X value and a Y value. Every time you see a point on a graph, hey, look, if X is 4, then Y must be 0. Oh, hey, look, if X is 4, then Y must be 0. How many unknowns in that equation? Boom. I got 1 unknown. I can solve for 1 unknown. Here we go. 0 equals A times, well, 4 minus 0 is 4 squared plus 3. 4 squared? 0 equals A times 16 plus 3. Be honest now. How many of you want to write 0 equals A times 19? Good job resisting the urge. The most common mistake right here is that people go, oh, 16 plus 3 is 19. And they write 19. But multiplication comes before addition, so we can't add those together. But what we can do is subtract 3 from both sides and write that as negative 3 equals 16a. And what we can do is divide both sides by 16 and write a equals negative 3/16. Now, I know what you're thinking. Ooh, I don't know how to divide 3 by 16, so I'll get out my calculator. Hey, I got a better idea. Nothing wrong with writing negative 3/16. It's a perfectly good answer. We don't need a decimal. And if it's a decimal, you're going to want to round it because 3/16 is 0.125 plus 0.0625, which is 0.1875. And then you're going to say, oh, well, that's about 0.2. And then you're going to be wrong because the stretch factor is not about 0.2. It's exactly negative 3/16. Hey, look, the equation of this parabola is y equals negative 3/16 times x minus 0 squared plus 3. Do I need to write the minus 0? It's understood. I could just as easily just write x squared. But I think that's a good reminder that the vertex is at 0, 3. Questions? Let's do another one. Hang on just a second. We've been roofing through my stuff, stealing my Expo board cleaner. I could have sworn I had 2 or 3 more of those. Oh, wait. Nope, not it. Okay. Well, I just have to fish it out of the trash and try to get a little bit more out of it. Okay, here we go. Turns out that Mr. Erding got his degree in aerospace engineering. And the reason he got his degree in aerospace engineering is because he thinks that rockets are cool. So one day he's playing around and he buys a little model rocket. And he launches it. That's the flame. And it proceeds to shoot up into the air, and the rocket motor burns out because that's what they do. Does anybody even shoot model rockets anymore?
Yeah.
Oh man, when we were kids, they were a blast.
No, we kind of.
You'd order the little engines, and you could, if you could find your rocket, then you could put a new engine in it and set it all up again. They had little parachutes that popped out, and they would come down. And half the trick was finding them because you needed a huge field, and then something would go wrong with your rocket. And you had it. You're way over there on the soccer fields, and you were pointed towards the stadium, and it would go and disappear into the woods. And
Fireworks?
What?
Was it like fireworks?
They had some.
I remember like each
Some
time
of
Fourth of July.
Yeah, but this was way more fun. Because fireworks, you stick them in the ground and light them. These ones, you had to build them and then get the little launch pad thingy and set it all up. So anyway, the rocket goes up into the air, and we're going to assume, for the sake of the problem, that the little parachute doesn't work. And so it just goes up and comes back down again. We don't want to have to deal with the floating down part. And it travels, let's say, I'm making this up as I go along, 1,500 yards. It's a good rocket, 1.5 kilometers. And it goes up into the air and reaches a maximum height of, let's call it 1,200 yards. And we want to know the equation of the flight of my rocket. Again, repetition. If I can come up with an equation, and if I build the same rocket over and over and over again, I should be able to tell you exactly what it's going to do, where it's going to be at any time during its flight, because I'll have an equation. So here's the first question that I have to ask myself. Where do I want to put my graph axes on this problem? Should it be just like the rabbit problem, or is there an alternative that might work better? What do you guys think? Rabbits would just be right here. There's the vertex. We'll just make that the y-axis, and then we'll go halfway out in each direction. Is there another alternative? You sort of shook your head a little bit. What were you thinking?
That's like the top right. It's like the y-axis is where the rocket is.
So you're thinking maybe we just put a y-axis right here?
Mm-hmm.
What do you think? Any advantages or disadvantages of either of those?
You don't have to look at parts of the graph right now.
Yeah.
The rocket's starting from 0.
Yeah. I like starts from 0. And there's going to be a lot of problems. Like, for example, if you wanted to have a kicking competition and you wanted to plot it on a graph, well, where are you going to have everybody kick from? You're going to have them all kick from 0, right? It wouldn't make sense to say, well, we're going to have a kicking competition. I need to know how far you kick so I know where to start you. What? I don't know how far I kick. I'm going to run out and kick it as hard as I can. So let's put everybody at 0. So I like that idea of this will be the y-axis. So what are the coordinates of all the points that I know on this graph? Take a minute to think about that. Coordinates of every single point that I know for sure on this graph. Taryn, can you give me the coordinates of 1 point?
0, 1500.
0, 1500. Brett, can you give me the coordinates of another point?
0, 1200.
Right here?
Yeah.
Does the rocket go there?
I mean on the flight path.
Call that a brain fart, right? It's like, I just, for some reason, that popped into my head. So what else? Is there one? Can you think of another one on the graph?
Yeah, 0, 0.
Yeah, 0, 0. That's where we launched from. Excellent. Thank you, Brett. Need one more. Oh, look, I got a volunteer back there. Tristan.
I was just going to say, shouldn't it be 1500, 0? That's why.
Yeah.
Oh, good call. Good call. Everybody okay with that? Gonna change that to 1500, 0 instead of 0, 1500. Good. Thank you. You notice I didn't even, I was just like, I know there's a 1500. I know there's a 0. Yeah, I'll write it down. Good. Hey, I need one more.
750, 1200.
Say that again.
750, 1200.
Okay, I heard something different. I was like, wait, what? 750, 1200. Willem, could you please explain for those of us who are a little bit slower on the uptake than you, why 750? I get the 1200, that's the height. Why 750?
Because it's a parabola, so it's symmetrical on either side.
Boom, symmetry. It's got to be halfway. All right, next question. What numbers go where? Take a minute to think about that. What numbers can we just plug in right now into our equation? Go ahead and think about that one. And then I'll ask some people who haven't spoken much yet. Oscar, get ready. It's okay to not speak much. What numbers could go where into that equation? You don't have to solve for anything. Don't do any math yet. Just think about what numbers go where. Oscar, do you want to give us one? Or two?
K.
What about K?
It's 1200.
Sweet, plus 1200. What goes along with K? Yeah.
H.
H, what's H going to be?
750.
Avery, what other numbers can I plug in there?
X at 1500.
And if I'm going to put in an X, I got to put in a?
A 0.
Malaysia. What do I absolutely positively not know? Boom. And now I can solve. 1500 minus 750? 750. Agreed? Turns out it doesn't matter whether you use this point or that point. They both have y equals 0. And if I plug in 0 for x, I get 0 minus 750. And when I square it, I get a positive number. But if I plug in 1500 for x, I get 1500 minus 750, which is 750. And when I square it, I get a positive number. Doesn't make any difference which of these 2 points you choose. You should get the exact same answer. So let's do some simplification. 0 equals a times 750 squared. I'll be honest with you. I'm not totally up to speed on my 75 times tables. So we're going to need a calculator. Who's got it? 750 squared.
No.
562,500.
So what you're saying is that 75 squared equals 5,625?
Yes.
We should commit that to memory, because we might need it again sometime. Wouldn't it be cool if you knew all those? I bet there are people who are so good at math that they just memorize all those, like every perfect square. To a certain point, anyway. That would be fun. Plus 1,200. So let's see. So if I add 562,500 plus 1,200, I get 563,700. Agreed? So is that what I'm going to do?
No.
Good answer. No. Why would I add those?
But I'm saying if you were to.
Oh yes, you're right. You're right. That's why I asked the follow-up question. Is that what I should do? And the correct answer, of course, is don't be ridiculous. We're going to subtract 1,200 from both sides. 562,500. We're going to divide both sides by 562,500. A equals negative 1,200 over 562,500. Put those calculators down. Don't even think about touching your calculator right now, because we're going to take a little nostalgic trip back to the 4th grade.
Wouldn't 1200 stay negative?
I just moved the negative up front.
Oh, okay. I didn't see it.
Yeah,
I was
no problem.
confused.
Yeah. General standard math notation says that you don't put the negative in the numerator or the denominator of a fraction, you stick it out front. So I automatically just shove it out front when I see it. Let's take a trip down memory lane. This is times 100, right? 12 times 100. And this is times 100, right? So I can actually cross off both those zeros and both these zeros. Hey, what are the factors of 12? Anyone? Factors of 12.
2 and 6.
2 and 6, but I can go further, right?
3 and 4.
But I can go further, right?
12 and 1.
Useless, but yes. No, you're right. It's true. But if I've got 3 and 4 or 2 and 6, can't I factor more? What are the factors of 4? 2 and 2, right? So I could write this as 2 times 2 times 3. Those are all the factors of 12. The reason I'm doing this is because I do not want a decimal. I want to simplify this fraction. Sometimes you can just tell your calculator, hey, simplify this fraction for me, but sometimes you can't. So does 2 go into 5,625? No. Does 3 go into 5,625? How do you know?
Because the 3 can go to the 5.
Can't it? 3 goes into,
Could.
because 3 goes into 15. Do you guys know the trick?
No. Did you add up the numbers?
5 plus 6 plus 2 plus 5 is 18. Is 18 divisible by 3? Then 5,625 is also divisible by 3. Nice little trick. So this is going to be 3 times, and now I'm going to have to do some division in my head. 3 goes into 5 once, remainder 2. 3 goes into 20, because I carried the remainder down. 3 goes into 26 8 times, remainder 2. 3 goes into 22 7 times, remainder 1. Notice I'm just carrying the remainder over to the next one. And 3 goes into 15 5 times. It's 3 times 1875. And now I can reduce the 3. And my stretch factor is going to be negative 4 over 1875. and I'm gonna go write my equation. Y equals -4/1875 x minus 750 squared plus 1200. There's the flight path of my rocket. And if I make the same rocket over and over and over again, it will conform to that equation every single time. Which, if I want to sell people my rockets, might be nice to be able to just tell them that. Oh, by the way, when you launch this, that's what the flight path is going to look like. Makes it easier to sell it to them because now they know what it's going to do instead of just experimenting. Questions? Somebody with a calculator, 4 divided by 1875. Melissa,
0.0021.
does it keep going?
Yeah, 3333. They're repeating.
Do you know that it's 3 repeating, or are you just assuming
No, I
it's 3
don't.
repeating?
I would say.
I hate 3 repeatings. I hate the notation, I hate the use, I understand they have their uses. We don't know that that repeats. You may guess that it repeats. We don't actually know that it repeats. So, but either way, you're gonna have to round it, aren't you? Guys, writing this as an answer is actually not really acceptable because there's no way for you to enter an equation with a repeating decimal into your calculator. You just have to sit there and type 3s until your calculator runs out of memory, and then you haven't typed in the whole number because there's more 3s maybe. This is why I like fractions, because you're gonna have to round that. What most people are gonna do is gonna say, oh, I'll just write that. Hey, guess what? The equation's not accurate anymore. Or they might say, oh, I'm just gonna write that. Well, now it's even less accurate than it was. Or they might say, 0.002. That's a really tiny number. Let's just write y equals -0 times x minus 750 squared plus 1200. And of course, hopefully we all see the problems with that equation. Wait, my rocket doesn't do anything. Oh yeah. So, simplified fractions, generally, really, really good. If you go off and do a field like engineering, there are actually ways to figure out how many decimals you should draw that to. When you're dealing with tolerances and accuracy, you might say that for the purposes of my problem, I need that many decimals of accuracy. And so then you would program in 0.002133 and say, okay, that is as accurate as I need my calculations to be. What you would do is you would do an analysis and figure out that if I go to here, then that'll tell us where the rocket lands within, say, 2 yards in each direction. Hey, good enough. I'm okay with 2 yards. So I'll round it off there. Well, what if I want to know within 1 yard? Well, then maybe I need to put another decimal on my equation. Or maybe I don't care as long as it's within 20 or 30 yards, because it's just going to land in a giant field and I just need it to be over there. So then maybe you say, oh, we'll just put that. But that's a calculation that you have to do when you're deciding how accurate should my numbers be. For our purposes, 100% accuracy is better than some other percent accuracy. All right. This is wrong, because this says that fifth period is only 30 minutes long and then T3 is 1 hour and 10. So I don't know what time. Oh, I guess I could look at that. I copied the first column down and then just put both of those on. And then I was looking at it going, wait a second, we don't end at 11:25. So we end at 12:10. Oh, this is all messed up. No, I'm gonna have to I'll just change this at some point. We end at 12:10. 12:10. And then we have T3 from 12:10 to 12:40.
In this class?
In this class, yes. The way this is gonna work is that you get T3 once per period, which means you always have an opportunity, each teacher has an opportunity to see you. And it could be used to either give you something to work on. If you teacher has nothing for you to work on, then it could be used for, work on another class if you're behind on something. So here's what we got. I have a worksheet for you that has 2 more of these problems. And my plan had been to have this take us until that time and then have you do that during T3. But, and I don't really want to start the next topic. So here's what I think we're going to do. Let's do the worksheet. It is in Google Classroom. Go ahead and pull out your Chromebooks, fire them up, go to Google Classroom. I'm going to have you turn in these classwork worksheets in Google Classroom, but you may do them on paper and turn them in by taking a picture just like you did when you were at home. You can either do it in Canvas or DocHub, although I hate DocHub. Canvas is way better. Or you can do it on paper, but either way, you're going to turn it in as an attachment in Google Classroom. Okay? So I'm going to go ahead and shut off this stream with it says one person's watching. Ooh, how exciting. I don't know what to say. I feel like there should be a thing off to the side with chats if maybe that means nobody's watching. Okay, well, now that I've rambled live on YouTube for like another minute,